Hey guys, so here's the notes for 5.1. We're going to be talking about properties of exponents. Okay, so anytime if I'm going too fast, just make sure, especially I'm going to explain what these properties are. I would pause the video, write it down, and then listen to what these properties are. Okay, so we have the product of powers. That means when we multiply and we have the same base, what we do with the exponents is add them. So here, notice the example, we have x to the fourth times x squared. Well, the bases are the same. Notice we keep the base x exactly the same, and all we do is add the exponent. So 4 plus 2 will give us 6. Okay, power of a power. So this is when you have a base, it has an exponent, and then it's raised to another power. So what happens is we take those two powers and multiply them. So here, our base is x. We have x squared. Squared is our power, but then we raise that to another power of 4. So what we did is we keep the base exactly the same, x, and then we do our two exponents. We multiply them 2 times 4 to give us 8. Okay, power of a product. This means when we have multiple terms that we're multiplying and they are raised to the same exponent, we can distribute it, okay? Now, we have talked about before, right, in our polynomials and in our quadratics unit, well, when we have something maybe like this, okay, here we always said you cannot distribute the exponent. But when you either multiply or you divide terms, you actually can distribute the exponent, okay? So just make sure you know the difference there. So adding and subtracting cannot distribute exponent. But with multiplication and division, you can. So here, notice we have 2x, and that's all being taken to the third power. So we distribute that cube to the 2 and to the x, okay? So we have 2 cubed times x cubed. Now, anytime you have a number, you do need to evaluate. So we do have to evaluate 2 cubed to give us 8. And then we have 8x cubed. The reason we have to evaluate is that's how we're going to simplify. So make sure any numbers you evaluate all the way. Okay, now our negative exponent. So this, what happens when we have a negative exponent is that we need to flip, meaning that we flip the fraction. So if the term has a negative exponent and it's in the numerator, you move it to the denominator, and vice versa. So if it has a negative exponent and it's in the denominator, move it to the numerator. So here we have 6 to the negative second. So there I put it in the denominator, and I do put 1 on top of it. So I have 1 over 6 squared. Now remember, this is a number, so I do need to evaluate. So 6 squared is going to give us 36. So I have 1 over 36. Okay, next one is the zero exponent, okay? So what this means is anytime you have 0 as your exponent, your value will always be 1. So we had 10 to the 0 power, that's just going to equal 1. If we had a billion to the 0 power, that's going to be 1. Even with variables, if we have that to the 0 power, it will always equal 1. Then we have the quotient of powers. So basically what this means is that when we have the same base, what we do with the exponents is we subtract them. So here, notice our example, we have x to the 10th divided by x to the 4th. So notice that we have the same base and we keep it the same, it doesn't change. And what we did is we took our 10 and 4 and subtracted them, and so we got x to the 6th. And then our last is the power of a quotient. So as I said before, when you have terms and you're multiplying or dividing and they're being raised to the same exponent, you can distribute. So if we have a divided by b, what I can do is distribute that exponent to the numerator and to the denominator. So here, notice we have 5 over x to the third. And notice that the entire fraction is in parentheses. So that's when we know it's being raised to the entire exponent. So I distribute that cube to the 5, and in the denominator, distribute to the x. So I have 5 cubed over x cubed. Now remember, with any numbers, I do need to distribute. So I do 5, or I need to evaluate. So I do 5 cubed, and you can plug that into your calculator if you need to, and I get 125, and then I keep in my denominator x cubed. Okay, make sure you have all this written down. Now we're going to go ahead and apply these exponent properties to the examples. Now, when we are doing the examples, you do not need to memorize the properties. You just need to make sure you know how to use them. Okay? Okay, make sure you watch part 2 of our 5.1 notes.